All right, so let's see. We are going to talk about shared coordinates. And last time I showed you, the process of using some of the site tools that shipped out of Revit, the ability to create these different ways of topo surfaces, the manual method of creating topo surfaces, the way to change and modify the topo surface settings. And we also talk about how to create a topo surface using points, a point data set, and a point and a CAD data set. And we leave it there. I say also I was going to go over a few more topics that I did not have time to address, and that was the shared coordinates topic. And so let's talk about Revit insertion point and how you can get control of where that insertion point is. For today, for this little exercise, I'm going to use the data set in Google Drive called Share Coordinates. And if you go to Share Coordinates if we go to the Google Drive, there is login. There's a folder that I just created this afternoon. It's called Share Coordinates. Oh, wrong account. And I'm going to share this link with you as well. I'm going to paste it in this chat panel. And while you download that, it should be quick. Let's talk about some of the logic behind shared coordinates. So I'm sure you're all familiar with Revit coordinate system or with AutoCAD coordinate system. AutoCAD coordinate system it's pretty straightforward. There is a single insertion point, which has the coordinate 0, 0. There's an absolute coordinate that drives the coordinate points of the rest of the information in a CAD world. But the Revit world, it's a little more complex. And the complexity is that the software was designed to have a relative insertion point. Let's start by saying that you may be already aware that the maximum size of a project it's 20 miles. So it's the equivalent of having a big cube or a big sphere inside a Revit that has a maximum extent of 20 miles in X, Y, and Z directions. If you exceed this size, Revit's going to get angry and it's going to display this notification that the geometry, typically DWGs have this problem, that have an extent greater than 20 miles may have problems with reliability, indivisibility, and graphic behaviors. You can ignore this message, but be aware that CAD files that are larger than this extent produce very irregular behaviors in visibility. So, for example, you can switch to an elevation, and then the elevation is not displaying what it's supposed to display, or you cannot complete a rendering task, or you don't have the ability to display anything in a 3D view, for example. You switch to a 3D view and you don't see anything. It's probably the result of having a link or a CAD import that is larger than 20 miles. So if you receive this message from a CAD import, in Revit, it's better to not import it, because then you're going to avoid yourself a big set of troubles on this visibility display. So inside Revit, there are 3 points you must be aware. Well, before I move into the points, let's also remember that in Revit, you have 2 orientation, the true north and the project north. I taught you last class how to set the project north in relationship to the true north, and how to set the angle of declination between them by picking a reference plane. The view cube in Revit usually display 2 alignments. The orientation wheel will display the true north orientation, and then the cube is going to display the project north orientation. And then it's a property of the view. Once it's set up, you can switch between project north and true north. So the points that you must be aware in Revit are 3. One is called the internal origin, which it's placed at the center of the maximum allowable buildable space. The internal origin up to Revit 2020 was invisible. I think in Revit 2021, they turned it up. So now you have the ability to see gizmo coordinate at the internal origin, but you cannot do anything about it. Or an internal origin, it's fixed in space. You cannot move it, you cannot edit it. It doesn't report any coordinates. And it's only relevant when you're linking models origin to origin. That means the 20-mile space of the one model with the 20-mile space of another model in the same spot. Then in addition to this internal origin, which doesn't have any coordinates, you have these other 2 points. One is called the survey point and another is called the base point. The survey point, it's a point that it's available under the site category, and it's a point that displayed in the shape of a triangle. And the survey point usually by default has the name called survey point internal. One of the things about this point is the user has the ability to select it and drag it in X, Y, and Z, and that's going to determine the new shared coordinate system. So unlike AutoCAD that has a fixed origin point that you can refer to, the shared coordinates, it's a relative point and it floats anywhere in the 20-mile space. The default values of the coordinates are 0, 0, 0, and 90% of your time, you're always going to keep this survey point with these coordinates. Then the other point that it's important to understand is the base point. It's also called the building work point. And the building work point, it's a secondary reference plane, a secondary coordinate system that report coordinates relative to the survey point. And what's the relationship between these 2 points? Well, the survey point is usually snapped to a point that it's agreed by the project team with the civil or the survey engineer. The survey point is usually the intersection of 2 streets or the location of a geodesical survey mark. And if you walk in cities, you probably see them in sidewalks or at street intersections. But usually it's a monument identified by the civil in agreement with architecture as the point that is going to anchor all the consultant's model in space, the anchor. And then the project base point, it's a secondary defines a secondary reference system that allow architects and discipline to define an alternate elevation reference. And why this is important? Well, sometimes, architects and consultants need to have an ability to report elevation relative to the sea level or relative to the ground level elevation. And for Revit to understand, how do you want to measure the level elevations, then they need to have two different coordinate systems that are interconnected. Another importance of the Revit of the project base point is that it reports the angle to the true north. And this is a declination that I show you how to set up in the previous class. The project base point, again, has the ability to report coordinates using the north, south, east, west system. And you can identify a different elevation, usually associated with the ground elevation, to allow consultants. Structural does this very often. They usually don't define elevations relative to the sea level, but they do it relative to the ground level of the building. And it also allows levels to report a different set of elevations. When we when we start linking information inside our project, you can link AutoCAD files, you can link DWGs, you can link MicroStation, SAT. Now you can link Rhino files as well. And then you will be presented with options as how do you want these models to connect. The simple way to anchor points between projects is to have all the consultants start from the internal origin. Internal origin, like I say, if it snaps with the survey point and the project base point, and and that's by default, and you send your consultants a footprint of your building, the levels, and the grid and the main grid lines, then that becomes the starting point for your consultants. That usually happens when you have a really well-defined BIM execution plan that establishes that as a BIM strategy. But sometimes consultants start at different points in time. Sometimes the consultant's not even brought into the project when the project starts. And so oftentimes consultants start projects using different references. And so in order to combine them into a single anchor point, then there's the need to establish what's called shared coordinates between consultants. So any question here about these concepts or these 3 points? Internal origin, it's fixed, it's now is visible, you cannot change it, you cannot move it. Survey point is the 0, 0 of Revit, but it's a relative point, it can move in XYZ, and you snap it to a point that is agreed upon by the architect and the civil. And the base point is an alternate coordinate system that defines a different set of elevation associated with levels. And it's usually aligned with the intersection of two main grids, column grids. All right. So what are the steps to establish a shared coordinate system? Okay, if we have 3 or 4 different projects that are not aligning, one of them needs to determine what is the shared coordinate system. Typically, it's used the architectural model, in alignment with an AutoCAD site plan. Once there's an agreement about where that point needs to be, this is called the source file. So this architectural site model is sent across all the different consultants so that they can start the model acquiring the shared coordinate system from this source file. If the consultant already has some geometry developed in their model, the source files is linked into the consultant file and be aligned, rotate, or move. And once the source files is aligned with the consultant file, we acquire the shared coordinate system from the source file. Acquiring shared coordinate systems is the equivalent of reading from a link file the X, Y, and Z coordinate, the specific location of the shared coordinate, and make the consultant's file align with the source file. This is something that usually happens once in the lifetime of a project. So getting it right from the very start, it's one of the responsibilities of the BIM lead within the different consultants organizations. And also, it's good that, the BIM lead of the execution of the project write down the process of aligning coordinate system in the BIM execution plan. So there are two ways of coordinate system you can acquire and publish. Acquire means grabbing the point from a source file and align it with your consultant file. And publish means pushing your point into the consultant's file. Now, we don't want to be the owners. We don't want to own the responsibility of publishing coordinates into a consultant file. And so to keep the responsibilities in place and not infringe into a consultant's project, it's best to acquire coordinates using this 4-step process. Identify the project that is the source file, link the source files into the consultant files, align, rotate, and move the link, and then acquire the shared coordinate system. So then moving forward, after this process is completed, then files can continue be linked via shared coordinates. That's one of the options when you link Revit files. And in the properties of the model, you're going to see that the parameter called share site it's renamed as internal. That means it's in alignment with the source file. So we're going to do a quick exercise where we establish shared coordinates in a model using a CAD file. The files that I provided to you have 3 links, and it has one DWG called site civil. And so we are going to start a new project from scratch. And then we're going to link the CAD file. And we're going to use this CAD file to establish shared coordinates and establish this as the source file. And then this new site model is going to be linked inside each of these disciplines. And then we're going to acquire shared coordinates. So that's the next exercise. So let me know if you need time to download these files. Otherwise, go ahead and launch Revit and start a new project from scratch. So I'm going to create a new project and use the architectural template. And then I'm going to switch to the site plan because the site view has displays by default the coordinate systems. Now, by default, the project base point, the survey point, and the origin are exactly in the same place. The visibility of this point is under the site category in visibility graphics. So if you type VG on the fly and scroll to the site category, you're going to see that there are there's a checkbox called internal origin. There's another one called project base point and another one called survey point. The 3 points I just talked to you about. And the gizmo in the X and Y direction, that is the only visual clue of where the origin is. In the past, it used to be invisible, but now it's enabled. So now that I have the 3 points, I have to switch to the south elevation. And there are 2 things I'm going to do. First, it's important to establish what is the sea level. Sea level is usually 0, 0 relative to the sea level. So I'm going to rename level 1, and I'm going to call this sea level. And when it says to confirm rename, I'm going to say yes. And then there's another one, there's another level above this that it's level 2. I'm just going to call this ground level, assuming that that is the, I'm going to rename all the corresponding views as well. And then this ground level, it's approximate, I'm just going to raise this to, let's say, 200 feet. Just for now, it's a placeholder. All right, so let's remember what we're doing. We are creating a source file that's going to hold the shared coordinate system. And this file, once it's completed, we're going to send it to the consultant so they can acquire shared coordinates from this source file. So this is like the source of truth on shared coordinate alignment for the system of projects. Okay, after I do this, then let me show you. You don't have to open AutoCAD, but I have this file open for you. This is the representation of a civil site. I sent it to you as well. You don't have to open it. But inside this project, there is it has all the existing topo. There's a reference to the access road, the property lines, some easements. And in addition to that, you have a reference to the footprint of the building and the intersection of 2 ground center lines. So this column center lines, it's something that if the civil doesn't have it, if you are deciding where the file needs to be, you have to link the survey and decide where in the site your project's going to be sitting at. That's usually the designer's responsibility. And you work with the civil engineer defining what is an insertion point of the building and what's the rotation of the building relative to the true north. And so all this information that you find here, it's information that is agreed upon with the civil engineer. Information you coordinate with the with civil, and then the 2 pieces of information you need to define with the civil engineer is where 0, 0 is going to be and what's going to be the project base point. And so when I look at these coordinates, notice the elevation. This is about 64. And then when I select another one, this elevation is 658. we need to define what is the ground elevation for the building. And that's information you can get directly from AutoCAD. So I know that this is sitting between elevation 64 and elevation 58. So these elevations are the distance between them. It's let's just confirm, this one is 66. This is 64. We're going to do an elevation of 60, and that's going to be the and this is 58. Yeah, I'm going to say it's 60. What is the ground elevation? That's always sometimes it's a working process, but and then it gets defined over time as the define gets refined into DD. But you need a placeholder. And right now I decided it's going to be 60 feet above sea level. And so I jump into Revit and I transfer that information here. So the ground level is going to be 60 feet above sea level. And I have a level that's going to be associated with the shared coordinate system, and a level that's going to be associated with the project base point, which is the alternate elevation system, and allow levels to report elevation relative to the project base point. Okay, so now I have this elevation here. The other piece of information, it's an alignment point. Like I say, this is the alignment point, the intersection of A and C. You really need a way in AutoCAD to understand where that is. And then most civil drawings are aligned with true north. And so for the purpose of this exercise, I mean, this line represents project north. All right, so just a word of warning, a word of caution. Sometimes the engineer provides you a survey, and when you, and these surveys are, or the work of the civil are created in a program called Civil 3D. And when you open them, this is an example of a survey, a real survey of a real project. And when you zoom extend, zoom extend, notice how the project becomes a tiny, tiny dot. And then there's this big line connected to a point out of space. And so this is a bad project for Revit, because if I link the file the way it is right now, then it's going to report the maximum 30 mile, the 20 mile limit. This is going to exceed the 20 mile limit. And so you need to make sure that you delete everything around the CAD file. And again, is it our job to modify the consultant's file? No, but if you want your civil engineer to work with you, make sure to know what to ask. And so the ask for the civil engineer is to provide to you a file whose model extent it's less than 20 miles. And the way to check that is to open the civil file and then zoom extent. And if it's displaying like that, it's not a good model. And so what the civil engineer needs to do in Civil 3D is to export this model using the agreed shared coordinate point as an insertion point. And in Civil 3D, it's super easy. Do I have it here? Yeah. This is Civil 3D. And obviously, most of us don't know Civil 3D, but civil engineers always put excuses. Oh, it's not my job to do that. But this is a one-time thing they need to do. A civil engineer will just go to the output, and then you say export civil 3D, and then export set in the export settings. Choose a different version and export it for you. And then that file is going to be ready for import in Revit. So it doesn't take anything to a civil engineer to do that. And if they push back, you can just send them this screen on how to do it. It takes just seconds to do it, to be honest. So I'm going to close this. This is just a word of caution to avoid future problems with Revit. Okay, so this is that was the CAD file that we're going to use. And let's bring it into Revit. So I have the sea level, I have the ground level set to 60. I'm going to switch to the side view. And then these things here are the elevation markers. Probably don't need them. I'm going to keep them around. But then we're going to insert the civil side. There's a question from Holman. How do we phrase what we're asking from civil? What is the terminology? Okay, so you need to ask civil to export the civil 3D drawing with an insertion point at the agreed monument. But that's a discussion you have to have with civil. What's going to be 0, 0? It's going to be, is it going to be the intersection of the street? Is going to be the end of the property line? Is it going to be the boundary, the easement boundary corner? You and the civil agree what that point is, and then ask him to provide you a CAD file with the 0, 0 at that coordinate. That makes sense. Awesome. All right, and so now that I have this CAD file, I'm going to link it into Revit. So I'm going to go to the Insert tab. I'm in the site plan in the project browser. I'm going to go into the Insert tab. I'm going to link a CAD file. Navigate to the share coordinate file and select the site civil. And for the first time, I'm going to use the 0, 0 of the CAD file with the origin of Revit. And remember, the origin point is the point that it's invisible of. This is the internal point. So when I link Revit origin to origin, these are the options. You can link center to center. Center to center is the geometrical centroid of the geometry with the geometrical centroid of the other geometry. You can do by shared coordinates. In order to do by shared coordinates needs to be established. So you cannot use that. Manual means that you're going to grab and pick a point on the screen for the origin and for the center. So for now, I'm going to use origin to origin. I'm just going to bring the visible layers. And then you're going to bring, I know the units are feet. Auto detect usually does a pretty good job at detecting units. But if you measure something and it doesn't add up, most likely it's going to be feet. Preserve color is going to preserve the colors from AutoCAD. I usually don't correct lines, even though we all want it to be straight, because easements cannot be compromised. And I also disable orient to view. So this 3D civil site is going to be brought into the sea level, and then I'm going to hit open. I'm going to zoom extent. Notice that this is the CAD file. when CAD files are brought into Revit, they are automatically pinned. That's a good thing. The elevation markers were left behind. So I may need to use this elevation. So I'm just going to move the elevation markers closer to the site. So I'm just grabbing both the elevation marker and the elevation view. So you need to do window selections, right? Because if you just select the marker, the view is left behind. Notice how the view is left behind. So to move elevation markers, you need to select the marker and the view. And to do that, just do a window selection. Notice how it says 2 elements, and then relocate it. I'm just using my mouse near the site. All right, and the reason I left this elevation way south is because if I switch it to an elevation, I want to be able to see this point. Okay, everybody with me? I just linked this origin to origin. I have not established shared coordinates yet. And now the agreement with the civil is that we are going to use these corner as the shared coordinate point, and we're going to use this as the project base point. So 2 points here. This is going to be the shared coordinate system, and then the intersection of the column A and 1 is going to be the project base point. All right, the CAD file, it's visible in every view. If I switch to a 3D view, you're going to see it. If I switch it to an elevation, it's going to be there. It's not view specific. Now I'm going to switch to the south elevation, and I am going to notice that I'm trying to find my elevation levels. And I'm going to go back to my site plan. I'm going to do the, I'm going to open the east elevation. And notice here are my levels. I'm just going to stretch them closer to the site. And the best way to do this is to grab the elevation empty circle, this circle that is next to the level, and drag it out. Again, the way to move a level extent is to zoom to the level end, select the white grip, and stretch it. Just stretch it, and you have to use a combination of the mouse pan and drag it. All right, this is more reasonable. Now I'm going to go to let's go to the north elevation. Notice how my levels in north elevation are still crop on one end. So I'm going to do exactly the same thing. I'm going to stretch the levels to intersect with the CAD file. And I'm going to do it for both ends of the levels. The alignment line from the bottom to the top forces the alignment to remain in place. And that's why level 1 and the ground level are exactly in the same place. So I modify the level extent both in the north and the east side. And I have my points of references to bring the Revit model. Okay, so I fixed the levels. I think I could bring my south elevation closer. All right, so now that I have the CAD file in place, I am going to define project north. And we did this exercise in the last class to relocate project north. make sure that the orientation in the site plan is set up as Project North. And then make sure your CAD file is pinned. Then I'm going to create a reference plane using the CAD line as a reference. So you go to Architecture tab, create a reference plane, and use the pick line tool to create a reference plane along Project North. And I'm going to use grid line number 2 as Project North and hit escape. That's all I need. So now I have a reference for Project North. Make sure your view is set up to Project North, and then you go to the Manage tab, and under the coordinates, now under the location, select where is it? Rotate Project North. Here it is. Rotate Project North. And then align and select a reference plane. That's my reference plane. And hit OK. And now I have the right orientation. If you fall behind, I'm going to do it again very quickly. All I did is I'm still in the side view. Go to Architecture, set a reference plane. The shortcut is also RP. It's on the far right end of this. And so use the pick line tool in the draw tools to select the CAD line. And I'm going to pick this CAD line, the line that represents grid line number 1. After I do that, then I go to the Manage tab, Project Location, and select the Rotate Project North tool from this drop-down, and choose the Align Selected Line or Plane, select the reference plane, and this is just a warning that it was successful, hit OK, and now that's Project North. And then you can switch back between True North, which is this one, and Project North. So I'm gonna stick with True North. Go back into the side view and select True North, but I know that I have my Project North set up. Now let's look at some of the properties of this point. When you select the Project North, notice that now it's rotated. You see this is rotated because I rotated the Project North. And the angle between True North and Project North, it's explicitly disclosed in the angle to True North parameter. Then when I switch to Project North, notice how it rotates. Okay, everybody with me here? All I did is set up Project North. I brought my CAD file, and now I am going to establish share coordinates. Now let's go back to this one. The process is as follows. We are creating the source file right now. This source file needs to disclose where the shared coordinate is. And then this source file is going to be sent to the consultants. The consultant is going to align, rotate, and move this source file. And then they're going to establish shared coordinates. So right now, we're done with number 1. We just have one more step to do. So on here, we decided that the shared coordinate point is going to be right here. And so all I need to do is grab the shared coordinate, the triangle, In order to select the right point, you can just hit Tab and notice how Revit cycles between project base point and survey point, project base point and survey point. So when you select survey point, click on the screen and just move it. Move this file and say, oh, I'm gonna, because Civil and I agree that this needs to be that point, I'm gonna use the move command, move from here to there. Endpoint, snap endpoint. Make sure you grab the right point. We don't want the project base point to be at that location. So that is the survey point. The circle, which is the project base point, was left behind. And then the survey point we talked that was going to be associated with the intersection of A and 1. Remember, the importance of the project base point is that it creates a secondary elevation coordinate system. So I'm going to snap the project base point to the intersection of A and 1. And then the other thing I'm going to do is change the elevation. Project base points are usually associated with the ground elevation of the building. And we said the ground elevation of the building was going to be 60. All right, this step is important. What we're saying is that project base, the shared coordinate system is going to be at sea level. The project base point is going to be 60 foot above sea level, and establish a new coordinate system for the levels. All right, now I'm going to save this file, and my source file, it's complete. So I'm going to call this, this is a library, and I'm going to call this library site, no, library share coordinates. Save it. And then I send this file, and I also send the CAD file, both files, to your consultants. And then you explain them that they need to acquire the shared coordinate systems from this file so that their models appear aligned. So any question here? It's pretty straightforward. Survey point, one location, project base point, another location at a higher elevation. And then I'm going to save this file. All right, so let's close this file. So I'm going to close it. And now let's open some of the consultants file. So first I'm going to open the structural model. In the files that I provide to you, there's a file called library link structural. Go ahead and open it. So I'm going to open library link structural. And this is the model created by the structural team. It displays its structural information. And notice how the project base point, the survey point, and internal point are in different locations from the site one. All right, so according to the process highlighted here, we link the source file, then we align, rotate, and move the link, but we never move the link project, and then we acquire the shared coordinate system. Okay, so let's do that. So I am going to, one thing I'm going to do that I think I forgot to do is to create the property lines in the other building, but I guess we learned how to do that in the previous exercise. Let me just check one thing here. I'm going to open the shared coordinate system, the file we created before, and insert the link properties. Yeah, okay. That's fine. All right, so we're going to link the other file. So we go to the we go to the insert tab. Then you go to manage links, go to the Revit tab, and we're going to add. Yeah, I know why it's missing. I know what was bothering me, that I did not create the grid lines in the previous file. So I need to do that before I do this. So bear with me. Let's go back and open the previous file, the library share coordinates, because I really need those reference lines in order to do proper alignment. So let's go back to the share coordinates file. Here's the CAD file. And I forgot to create the grid lines. And so under the architecture tab, we create the grid. I use the pick line tool. And this is the first grid in the project. So you just select the CAD reference line in the background. Again, you need to pick the arrow with the green line. And this is grid line number 1. And then we're going to do the other one. And this is grid line 2, but I'm going to rename it and call this grid line A. So I needed these grid lines in this model in order to do the proper alignment. And then, yeah, then I'm going to save this file, save, close the site. And I'm going to bring the CAD file here, or the site plan here. So is that clear? All I did is go open the file and create grid line number 1 and grid line 1 and grid line A. So then I go to the insert tab, manage links, add the share coordinates file. I'm going to do it origin for now. And when I zoom extend, notice how they are placed in a different location. The CAD file does not travel with a link file. We're going to link it later. But what travels with the file, it's the grid lines, the levels, and the location of the project base point and the survey point. So this is the file that was linked, and these are the linked coordinates. So what you need to do is move this file. Yeah, remember the steps in my deck says that align, rotate, and move the link, but never move your Revit project. This is an instruction for the consultants. So in the Revit model, move, align, and rotate the link, which is this link, but do not rotate your model. So I'm going to bring this link model, and I'm just going to align it to where it needs to be. So I just put it near this, and then you can just use the align command. The align command is under the modify tab. Align. When you use the align, you select the source location first, and then the destination location as the second click. It's a 2-click operation. So what do you want to align? Level 1. Where do you want it to go? Right here. Well, I think I did the opposite. Align, where does it need to go? It needs to go here. What do you want to move? The link. That's what it is. And I'm also going to align it in the Y direction. Where do it needs to go? What is that you want to, where does it need to go? What is that you want to align? So you can see now that this is the link file in the right location. I also need to change it in elevation. So I'm going to open the south elevation of this file. This is the sea level, which is incorrect. Remember that the ground level needs to align with the ground level of this library. So what I need to do is move this down by a level. I'll move it this grid line with this one. So the top of concrete level, that is the ground level. And all I did is align the ground level with the top of concrete level. And again, this is something that the structural engineers needs to do. That you probably don't need to do this, but I'm just showing you the process that your consultants need to undergo in order to align shared coordinates.
Cesar, what if you decided that like your building was no longer at 60, it was going to be at 50? Would you just not change any of this, like now that it's all linked in?
We will have to, if the project moves during the DD process, for example,
Yeah.
we will have to relocate the project from one elevation to another elevation. That is a command available here.
Oh, and so it'll just shift everything. Okay.
And relocate project, move everything except the links. And so relocate is a way to elevate the building by a certain amount should the level change.
But everything will reference correctly into it still?
Yes.
Oh, okay.
Yeah.
Thanks.
Okay, so I align the ground level with the top of concrete level. And I think my level, it's aligned properly in X, Y, and Z. And so according to my instructions to the consultants, align, rotate, and move the link. And the last step is for the structural to acquire the shared coordinates from the source file. So now that I'm here, I am going to go to back to the site plan. And I'm going to acquire the shared coordinate system of the link. And this is how it works. Step number 1, select the link file. This is the link file. Step number 2, establish shared coordinates by clicking the share site parameter in the link properties. This is step number 2. You're going to click this button. And I want you to look at this triangle, right? And so select the link, and this is actually the shared coordinates from the link. It's actually visible. Now you select share site, and this is a one-time operation in the life cycle of a project. What do you want to do? I want to acquire the location of the shared coordinate system from the source file into my project. And so you acquire the shared coordinate here and then reconcile. And look what happened with this point. Now, the point that used to be here, it's automatically moved to the same location as the link file. And now the site and the structural model have shared coordinates. What happened with the project base point? This project base point, it's specific to the discipline. So this has to be moved manually. The shared coordinate doesn't move for you the project base point, and you may or may not want to match the architecture. I usually like consultants to also match the project base point with the architect. So all I need to do is use the move command to select it from the point intersection to the intersection of A and 1 to force the point to be at the intersection. Just type SI, which find the intersection, and that's it. So this point, it has shared coordinates established. Now I can save it. In fact, if you select it, it's called internal. And now moving forward, the files, these two files can be linked using shared coordinates. So I'm going to save this file, and I'm going to close it. And now let's verify that this actually worked. To verify it, I'm going to open the shared coordinates file. This is the source file. I'm going to switch to a 3D view. And then I'm going to link this file. And because this is a one-time relationship, I can start using shared coordinates as a link option. And so I'm going to link in this site the structural file. In the previous step, we link this file into structural. Now we're going to do the opposite. We're going to link structural into the site just to verify the work. So I'm going to go to insert, manage links, and then I'm going to navigate to the structural file, which I just saved. Make sure you save it, otherwise it won't come up. And then in the positioning, I'm going to say by shared coordinates, because shared coordinates are already established. This option will not work if you haven't done the steps before. So I'm going to hit open here. Oh, I picked the wrong one. Add the structural by shared coordinates. Open. And then hit OK. And this building is going to be right on site. The structural model, it's exactly in the location that it needs to be. It's an elevation 60 of the file, and it's in the right position relative to grid line 1 and 2. And then the same process needs to be repeated by MEP, by any designer, and whatever other consultants you may have. That makes sense? Okay, we can continue doing this for MEP and for architecture, but I'm going to stop here. This was just the only other topic that I think I had not shown. I think the other topic I did not show was how to create building paths. So we can create a building path very quickly here using the topography, the link topography here. But before we move that, any question here? Any question on how to create shared coordinates, establish shared coordinates? It will enable us to have all the consultants anchor by the same point. In fact, if I turn that point here on their site, survey point and project base point, notice that both points are exactly in the same point, the same location. All right, I just want to show you also how to create a building path. A building path, it's a representation of the ground floor of a building in a topo surface. It's very easy to build. All you need is I'm going to use these lines as a way to create a topo, a building pad. But first, let's create the topo surface. So I'm going to go to the massing and site. I'm going to create a topo surface. And just like we did in the previous class, we're going to create it by import instance. This is by selecting a CAD reference file. And then I'm going to select the CAD file and tell Revit that the only layers that hold information on elevation are the topo major and topo minor, are these two references. So to make it fast, you can check none of this checkbox, select the topo major and topo minor. If you don't know what layers are on your end for a different CAD file, open the CAD file and search what layer they are. And that is the topo surface. I click finish. Let's see if I shade it. Notice how there's no pad, and therefore the structural model seems to be synced into the topo surface. I'm going to switch back to wireframe, and then I'm going to create a reference. I'm going to create a pad that's going to be at elevation 60 from sea level, and it's going to punch a flat surface into the topo surface. And so to do that, you go into the massing and site, and then you hit building pad. Building pad is going to open sketch lines to create a closed loop of boundary lines. And I have that loop already here. So if you see, this is the boundary. And all I need to do is to select those lines and give them an elevation of 60. So I'm going to use the pick line tool. The pick line tool is one of the options in the draw tools. And make sure that the height of the top of this is going to be 60 feet. But you can also reduce the thickness of the structural slab. But for now, I'm just going to keep it at 60. And then select the CAD file, the CAD lines that define the building boundary. Make sure this close loop. Make sure that they don't overlap. There's no gap in between the endpoints. If there's any problem, I will see them soon. And there it goes. And this is shaded. And there you go. Melissa, you have a great point. I could also have chosen the ground level with an elevation of 0. In fact, I can change that as well. And it's the same effect. Same thing. Two different references. And now the topo surface is punched by the level. It's the topo surface is punched by the new path. What Revit is not going to do automatically for you is to work the point levels around the pad. I mean, that process is grading, and this is existing, and that process needs to be designed. And grading in Revit is it's a little cumbersome. You have to edit the surface and then start placing points to a different elevation, establishing phasing. Make sure you do it at the right phase. I will do it for you. But that is a path. Any question? Okay, so that is the process of establishing shared coordinates. I show you the process using this simple 4-step. It's a one-time process in the life of a project. Oh, let's see something that could happen in the life of a project. Once shared coordinates are established, the model that was brought in will report the shared site in the instance properties. If this parameter called share site reports an internal point, that means that there's a correlation between the model and the host. They're sharing exactly the same coordinate system. But links could be moved by accident. And this happens quite often. Sometimes you're in the rush of creating a floor plan, you might inadvertently pick a column and move it 2 feet away. So in the event that you move a link that has established shared coordinates and then you receive this message, this is telling you that the shared sites in the structural model have been modified, but have not been saved back into the link. So Revit is attempting to maintain a relationship with the host every point, and so if this link moves and you see this message, your tendency is to click this button that says save now. But save now is not the appropriate solution for solving this warning. If you see this popping up, immediately click cancel, because save now is the equivalent of publishing, and that is the point of this slide. Saving now means aligning the host aligning the host file with the link file, or is the equivalent of publishing a site. And this is going to modify the link, and that's not correct. And so if you see this popping up, immediately hit cancel. And when you hit cancel, it's going to return it back to the original location. So we need to be very aware about this warning. Just hit cancel, and it's going to take it back to the previous location. And so the way to avoid that from happening is to select the file and pin it first. And second, if you're not going to use it for any references, you can also disable the selection of links. And so that link is not even selectable by any means. So pin it and disable the selection of links, which will is going to help you not to move the link. Okay. Any question about this process? All right, let's get started on the next topic. You can save this file. And let's talk about visibility, some of the visibility controls in Revit. So I am going to close this file. If you have trouble, feel free to speak with me after class. All right, let me see if I still have this here. There's a nice graphic that I want to show everyone. That's fine. Okay, visibility controls in Revit. It's a complex visibility controls in Revit it's a complex topic. I'm not gonna lie to you that the way in which you have control of how things are displayed in a view is the result of many, many different levels of hierarchy. And so there is a famous one. Oh, here is. This one is a good one. This is an image that was shared many years ago. about what is the hierarchy of visibility controls. And I can send you this link if you want to keep it. In Revit, there are two levels of visibility. There are global settings that define how things are defined by default. And there are view-specific settings where elements are controlled by view overrides. And so there is approximately 10 different levels of visibility control. At the bottom side, which are the global settings, it's are the model, the object styles. I'm going to open the file that ships with Revit. You don't have to do this, but we're going to do it in an exercise later. I'm going to open the file, the sample files, and I'm going to open the rack advanced sample project. Not the structural. Rack advanced sample project. So I'm going to discuss all these different levels of control using this model, and then we may do an exercise. If we don't have time, we'll do it next class. Let's go from the bottom up. So at the global level, we have the project object styles, and the object styles are the default settings on how everything displayed by category in Revit, category and subcategory. The object styles, it's a global setting. You go to the Manage tab, and at the start of right next to the materials, you will see the object styles. Object styles define how model objects, view-specific objects, and analytical objects are displayed on the screen. And so these give you access to all the categories in Revit. And then you have the default projection and the default cut line weight. You have the default line color, the line pattern, and the material. There aren't a lot of materials defined out of the box, but I guess topography, it makes sense that it's associated with site grass, but not always you have the default materials for different elements, because the elements from different categories may have a lot of different materials. So materials is usually left blank. So you have model elements, you have view-specific elements, which include all the tags and all the tags. And the default, notice that because these are view-specific objects, they don't have any depth, and therefore you only have projection line weights. Then you have analytical model objects, which are relevant only for structural use. And then you have imported objects, which disclose the CAD files and every layer that's part of that CAD file, and the default line weight of that CAD file. In addition to the main categories, you also have the default subcategories. The subcategories, you can expand the main category to display the different subcategories. So I'm going to go to walls, for example, and display, these are the different subcategories of the wall category. So every view is going to inherit the parent settings of the object styles, and the line weights are it's a numerical value that varies from 1 to 16. Now, those values, and you must know this already if you are a beginner These are listed. The actual value of these are listed under the line weights. In this particular file, it's metrics. These are listed in millimeters with all the different scales. And so by default, Revit displays 6 scales and 16 line weights. And you can define line weights for projection, for model elements, perspective, line weights. Notice the perspective is irrespective of the perspective views are only visible in 3D. And then line weight for view specific objects for all the different tags. Let me open, I think I have a version of this in feet and inches. So in the Google Drive, I believe one of the first ones. I'll change it very quickly. You know how to do this as well. I'm going to change the project units to meters, feet. I'm going to change the distance to feet. Oh, it is the length to feet and inches. And then I guess that's it. All the volume. Okay. Notice that now I have all my feet and inches scales. And when I check again the line weights, I could add additional scales that are somewhat correspondent to this. And so, and I had to, usually these 6 scales are equally distributed along this scale, and they will display the values in inches now. Oh, I know what I'm going to do. I'm going to create a new project from scratch so that you can see that table. Here it is. So it starts from a detail level 1 = 1, and it goes to 1/32 = 1. And then for these 6 separate scales, the line weights have different values. Notice that like line weight number 1 is the same for all the scales. And this is usually driven by the smallest increment you can print. But then when you go to line weight number 3, notice how it varies, and you go 4, it also varies. It becomes the line weight change based on the scale of the view. All right, so if you're not happy with how something prints out of the box, go to object styles to change it at a global level and save it into your templates. Okay, so that's at the bottom side of this. Then we have the visibility graphic overrides. When you type VG or VB, that's the shortcut for graphic overrides. And all you need, what you do this is to establish a view specific color and light weights to projection and cut lines. And so when you establish VG, you're actually creating view-specific overrides. Say, for example, I want the grid lines to turn gray color. Then I go to the annotation category, no, to the line, to the grids, grid lines. Yeah, the grids are under the annotation categories. And you can just switch them to halftone. And then all the grid lines are now gray. These are view specific because this only applies to this specific view, the entry level. If I go to the another view, it doesn't apply. So when you apply visibility graphic overrides, you can change the projection surface. You can change cut line weights. And then you can also change what's the detail level per category. I'll tell you when this is something that you may want to do. So say I want to display the full granular information about this model. So I'm going to switch this view to, let's say, 1/8 of an inch. And then I'm going to make it fine. I'm going to make it fine. And the reason I put it in fine is because I don't know, I want to display information about the doors and some of the furniture information. But when I turn this to fine, notice how I also display the internal information on the walls. And maybe the walls, I don't want them to display solid. I don't want it to display the internal layers. And so what I do is to go to visibility graphic, go to the walls, and then in this particular view, rather than inherit the detail level by view, I'm going to force the view to display in coarse for the walls only. And then I'm going to apply this. And notice how all the walls are now displayed in coarse view, even when the overall view is set up as fine. So applying different levels of detail level to different categories, it's one of the strategies to mix and match some of the element display. Say I want the walls to display a gray poche. So that's something I can also add as part of visibility graphics. Go to walls, then go to cut pattern. Cut patterns can now display foreground and background colors. I'm going to make this solid color gray. Hit OK. And now every wall that is cut will have a solid color. There you go. This is poche everywhere. And again, these are only applicable to this particular view because this is view graphic overrides. That makes sense. Oh, and I just noticed that I posted that link only to Holman. So let me change this. I'm going to change it to everyone here. All right, the next level, it's the override host level. These are internal. I don't know if you were aware, but in visibility graphics, you can also override host layers. And these are the different layers of assembles. You can apply different line weights. So, for example, these are the functions associated with the walls structures. You can have different line weights. I'll give you an example. I'm going to undo what I just did. There you go. I have this wall, and notice how the internal layers inside the wall are displayed with the same line weight. And now if I go to visibility graphics, I'm doing a detail, let's say I'm doing a detail, and I access the wall category and I override the cut line styles, I could say that the structure may have a color red, and the finish, it's going to be, I don't know why would you do that, but I'm just making the point here. Then you have this ability to apply color overrides to the different cut layer boundaries. Anyway, in that in the event, in the list of hierarchies, that is the hierarchy number 8. All right, and the reason this is a hierarchy because the ones at the top trump the rest of them. So visibility graphics override the project object styles. Let's go to the next level, phasing graphic overrides. And we were talking about phasing before. Phasing is going to be stronger than the visibility graphic overrides. And phasing is driven, and we have a whole class about phasing, so I'm not going to repeat that. But if I were to apply phasing to this project, let's say I'm going to have this was created in existing, and then notice the color change happened because this has a phase filter override. The reason this turned into gray, it's because of the phasing overrides that kick in when I apply a phase filter. And a phase filter is stronger than a visibility graphic override. And so if you find yourself that you can't change this color, or this, it might be a phasing problem. And so phasing apply this gray color to existing objects. And this wall, when I selected, was created in the previous phase and it wasn't demolished. So it's an existing object for this project. And that's why it inherits the color gray as a result of the filter applied to the view. So that is phasing. Then let's go back. Give me a second, I need to open the door. ¿Qué tal? Estoy dando clases, ya te doy las llaves. Disculpa. No problem. All right, so phasing is the next level in the hierarchy of objects. All right, the other one, the level number 6 is called the view depth. And the view depth, it's also called the beyond line style. The beyond line style, it's something that appears in categories of a certain structural elements. And so I don't know if you remember, but when we were talking about view range, there was a slide I showed that elements that fall under the view depth and they are part of a certain categories, then they will display in a different line weight. Let me see if I can get that. I may have it here. Yeah, here. Elements that fall between the bottom plane. Oops. Between the bottom plane and the offset view depth. And they are part of like the category. They are part of the structural category. They're going to display as hidden lines. And then windows, casework, or generic models that fall between the cut plane and the top plane, those are going to appear as above line weights. And so those particular line weights are called the view depth line weights. And the view depth line weights are available under the line styles. So you're going to see all these all these line weights with brackets. There's one called hidden, and then there's another one called overhead. And these line weights are driven by the view range. So those are going to be of a higher hierarchy than the phasing. Those are going to kick in above of the phasing. Okay. And then I'm going to close with this last one, which is called a view filter, and then I'm going to finish the rest. The view filter, I don't know if you guys have used it in the past, but a view filter, it's a color override to objects of certain category based on properties of the element. And so the view filters create a selection set of groups of geometry that meet certain criteria. For example, you can select all the walls that have, I don't know, a rating of 2 hours, regardless of the family. And then apply a color code to those families. And a view filter has a lot of strengths above view graphics and phasing and project object styles. It sits at level number 5. So to build a filter, and I'm going to use the columns. So I have columns of different, I have a lot of columns here of different type. But I just want to select all the columns that are 300 in diameter. And for those columns, I want to apply a green override, a green color override. So the filter is something that you define inside visibility graphics. So in visibility graphics, notice how the very last tab of the graphic override is called filter. And a filter, in order to create a filter, you need to create a search set or a selection set. And then you need to apply the color override to that. So I'm gonna create the filter selection first. So you go here where it says edit new. The selection can be set based on a predefined list of selections, or it could be based on a rule. I'm going to do it via rule. So I select the rule-based filter, create a new filter, and I'm going to call it just columns 300. And then my filter rules activate. And I'm going to say select all the elements that are part of the columns category. You can do a multi-category as well. And then these are the rules. The columns must have a family name, must have a type name that contains the word 300. So as long as you meet the rule, then you can apply a color override. And you can continue adding rules. Like this could be a combination of different rules. And you can do and or rules. And means that all the rules must be true, or is that any of the rules must be true. And this is, for example, to check the height of a wall. This could be a way to do some QA/QC. For example, you can create a rule that says, select all the walls that are less than 8 feet and give it a color code. And this will be your QA to find out which are the ones that are full height which are the ones that are ceiling height, or which are the ones that go to the underside of the roof. So I'm going to apply a filter for all the columns. And I'm going to say, add this selection criteria to the filter and make a cut pattern that's solid and that it's green. And it's a view specific filter. And so when I do this, then I didn't do it. Why? This is a column and it has a type name 300. Let's go again. So the graphic filter. Oh, it needs to be structural columns, not the columns one. There's a architectural column and there's also a structural columns. There you go. And the type name contains 300. I could also do it is exactly or it's equals or does not contain. And so you can play with the numerical values of the parameters to apply a filter. Let's see if they do it. Yeah, this I do it. Now all the columns that have a type name that contains 300 receive this override. Other examples of filters, I think I may have the Audubon files. I think I gave you this file as well in the previous classes. This was a real project. I just want to show you some real based filters. So this one is the first floor call out. They have all the call outs. When I do visibility graphics and look at the filters, oh, there I am. I thought there were some filters here. Nope, doesn't have. It was a bad example. I'll bring next class an example of filters in real world scenarios. Some of the ones I can think of, it's like quality control of the wall rating, wall heights, and selectively display of view types in plan, for example. In this view, you want to switch off the visibility of the sections, but not the elevations of a certain scale. You want to see the overall sections and the view scale of a certain size, and then you want to hide the small ones, the ones that view scale is less than, or the scale value is less than 24. Then you can create a filter to do that. To do that, let's say, for example, I go to visibility graphics, filters, add, and it's edit new. I'm going to add a new rule base, apply to the sections. And I say the sections must have a scale value less than, let's say, if the scale value is less than 36, then do not show them. And so I'm just, and maybe I should name it correctly. I'm going to call this, delete this one and rename this one. Sections that are less than 24. scale factor or less. And so all the sections whose scale is small scale are not going to display in the screen. Add this here and disable the visibility. And so if you notice here, some of them are going to disappear. Apply. Yeah. But then the large one, the scale one, the ones that are very large are still there because they don't meet that rule. And so you can collectively switch off the visibility, apply this to a template, and then the filter would selectively display sections of a certain scale, as opposed to displaying them all at the same time. Okay, so it's almost 7:25. I'm going to stop here. And next class, we're going to do a quick exercise where we're going to bring a file with multiple links, and then we're gonna try to attempt to understand the different hierarchies. Now, the ones I remain to explain are the override graphics by element, the line work, and 2 and 3 are not that common, but I'll show it to you as well. So we'll do a hands-on exercise on next class and finish this discussion in the context of links. We're going to build some templates and apply it to other views in the same project. So, okay, any question? The recording should be ready as soon as this finished, so you feel free to watch it if you want to rerun it. Email me or stick after class if you have a one-on-one with me. Otherwise, then I'll see you on Thursday. Have a good night, everyone.
Thank you.
Right. Bye.
Thank you.
Okay. Bye, Anne.